In this episode of Trigonometric Functions, we are going to deal with sine and cosine. Our saying or abbreviation for remembering our trig functions is SO, CA, TOA. SO was our sine of theta equals opposite over hypotenuse. CA was cosine of theta equals adjacent over hypotenuse. And TOA was tangent of theta equals opposite over adjacent. We're going to draw ourselves a little triangle here, try to keep it proportional. Some values on that triangle where our base is 8 inches, our hypotenuse is 10 inches, and we'll be looking for our altitude, as well as solving for the two angles that aren't the right angle of the triangle. So what trig function will we use? Well, we have a hypotenuse. We're looking for this angle here. We have the side adjacent. So we have an adjacent and we have a hypotenuse. So we're going to use our cosine equals adjacent over hypotenuse. Cosine of our angle theta equals our adjacent 8 divided by 10. We need to get that angle theta by itself. So we're going to use the angle theta, and the opposite of cos is the inverse cos. Second function cos. Put our 8 divided by 10 in brackets, and we'll find out what angle A is. So second function cos gives us our inverse cos. Bracket 8 divided by 10, close our bracket, and hit equals. This angle here, 36.87 degrees. Again, we drew it proportional. It looks like it's under 45 degrees, the way we drew the triangle. If it's less than 45 degrees, what that tells us is that our base should be larger than our altitude. So let's go ahead and solve for the altitude now. The a, the small a. Let's use our sine trig function. We have an angle of 36.87 degrees, and we have a hypotenuse, and we're trying to find the side opposite that angle. So let's use our sine function. So we're going to have the sine of 36.87 degrees equals our opposite over our hypotenuse, which we know is 10. So we need to transpose this. We can move things, cross multiply, move things diagonally. So we're going to end up with the sine of 36.87 times 10 equals our opposite. Throw our calculator back up, take the sine, and if you go alpha equals, it brings up your last answer. So the sine of 36.87 times 10 will give us the answer 6. So our A is 6. We could check this by doing our Pythagorean theorem. Our square root of a squared plus b squared equals c squared. So let's punch that in. So c equals the square root of a squared plus b squared. Bring up our calculator, clear that out, under square root, put our brackets up. We have 6 squared plus 8 squared, making sure to close our brackets, equals 10. Again, part of the joys of trig is there's another way to figure out to make sure you have the correct answer. So now if we're trying to find angle B, we can use any number of trig functions. I personally am going to go with tan here. Why? Because we've already used the other two. So, but by using tan and trying to look for this angle here, it's going to change our opposite and adjacent side. B now becomes our opposite, our side opposite the angle. and A becomes our side adjacent, the angle. We'll take the tan of theta equals opposite over adjacent. We'll transpose that, be theta equals the inverse tan bring up our calculator. We'll clear everything. Second function, tan, gives us our inverse tan. Open bracket, 8 divided by 6, close bracket, equals 53.13 degrees. If we've done this correct, our three angles, 90, 36.87, and 53.13 should equal 180 degrees. We'll bring up our calculator again, clear that out. We'll go 90 plus 36.87 plus 53.13, and if we did everything correct, our answer should be 180, and it is. The joys of trig, being able to figure out multiple ways and ensure you have the correct answer.